Welcome dear student. Today we are going to discuss regarding microprocessor to microcontroller. Before studying microprocessor and microcontroller, we must have to know about the microcomputer. So we are going to discuss this topic by considering the following points. So what is computer? What is microprocessor? Block diagram of microprocessor. What are the different features of microprocessor 8085? What is microcontroller? What is the block diagram of microcontroller? Features of microcontroller 8051, and what is the difference between microprocessor and microcontroller? So first, what is mean by computer? What is the basic operation performed by the computer? So computer is nothing but it is a device which receives the input. Input is nothing but it is the data and instructions. Then after receiving, it performs arithmetic and logical calculations or different types of computation. It will perform the different types of computations. Then it stores the data and instructions. Then what is the result of computation? It displays the results. So it displays the result. Then controlling all the devices that perform this different task. So these are the different operations performed by the microcomputer. So first, what is the main part of the computer? So it first receives the input. Input is nothing but the data and instructions. It receives the input to the input devices. So what are the different input devices? Input devices are, it is a keyboard, mouse, punch card, scanners, light pen, switches, etc. After receiving the input, it performs different computations. That computations may be arithmetic or logical. All these calculations or these computations are performed in the arithmetic and logic section. We call it as ALU section, that is arithmetic and logical unit. After performing the calculations, it stores the data and instruction into the memory device. The different memory devices are there: RAM and ROM, random access memory or read-only memory. After performing different computations in arithmetic and logic unit, then it displays the result to the output devices. So what are the different output devices? So we use monitor or LED, printer, CRT, etc. Then it control all the device that we call as a control unit. So these are the main parts of the computer, that is input devices there, output devices there, and different storage devices are there. They are the main parts of the computer. So first part is, it is a performing arithmetic and logical calculations, and this control unit, these are the main parts. These two main parts are combined together, that is ALU section and control section are combined together, and that we call as a CPU, that is a central processing unit. So this is the main part of the computer, and microprocessor is nothing but this CPU. So block diagram of digital computer is nothing but the CPU, and to the CPU input devices, we connect the input devices, output devices and memory, that become the complete computer. Communication of CPU with IO and memory. How it communicates? So the processor communicate with memory and input output devices using three set of lines. So group of lines or group of conducting wires are called as a bus. So what are the different types of buses? So three types of buses are there. First is address bus, then next is data bus and control bus. Address bus is unidirectional. For example, suppose input device is there. Input device give the information from the input devices to the processor, but there is not exchange from the other side. So CPU will not transfer the information to the input devices. That is only unidirectional. Same thing is a address bus is unidirectional, and data bus and control bus are bidirectional. CPU exchange the information to the memory through the bidirectional device because it can take the information from the storage device and it can give the information to the storage device. That is a bidirectional. So microprocessor 8085 having address bus is of 16 bit and data bus is of 8 bit. So when microprocessor is the heart of microcomputer, is it? So microprocessor will work as a CPU. So instead of CPU, we connect the microprocessor so that become the computer. So this figure shows the microprocessor. To the microprocessor we have connected input device and also we have connected the output devices and the memory. So this become the computer. So microprocessor is nothing but the heart of microcomputer. Figure shows the architectural block diagram of microprocessor 8085. It contains different groups are there, different blocks are there. That is, block diagram of microprocessor contains first is arithmetic and logical group. Then second thing is register group, instruction register and decoder, timing and control group, interrupt control group, serial IO control group. So these are the main blocks of the microprocessor. Out of that, this figure shows the pin configuration of group signals 8085. So what are the different functions of pin? What are the different pins group signal of 8085 is shown. Pin configuration and group signal of microprocessor 8085 are, that is, there are 40 pins. Out of that, 16 pins for address and data bus. That means address is of 16 bit and data is of 8 bit, but only 16 pins are used for address bus and data bus. So demultiplexing is used for this. Same pins are used for address as well as for data. Then there are 3 pins for status signals there, that is ALE, S0 and S1. All these things we have studied in the last year. So control signal are there, that is IOM, RD, WR and ready. They are the 4 pins as a control signal. Different types of interrupt signals, that is a trap and restart signal, that is a RST 7.5, RST 6.5, RST 5.5, INTR and INTA. These are the 6 pin. Trap is the highest priority interrupt signal, and INTA is the interrupt acknowledgement in response to the INTR. Then clock signals are there, 3 pins for clock signal, that is X1, X2 and clock out. Reset signal, 2 pins are there, reset in and reset out. Again there is a facility of direct memory access, that is a DMA request signal is there, 2 pins for that, hold and HLDA. Then serial IO signal is there, that means data is transferred to the output devices or data is taken from the outside, that is a serial input output device through SID and SOD line, serial input device or serial output device. These are the 2 pins, SID and SOD. And last is power supply signal, that is a VCC and ground signal. So these are the 40 pins. So 8085 has 40 pins. So what are the different features of microprocessor 8085? So first is, it is a 8-bit microprocessor. It can accept 8-bit data. Then 7 8-bit registers. What are that? A, B, C, D, E, H and L. So A is the accumulator. All calculations are performed in the accumulator. 8085 has 16-bit address. Hence 2 raised to the power 16. That means it can access 64 kilobyte memory. It generates 8-bit IO address that can access 2 raised to the power 8, that is can access 256 IO ports. Program status word PSW. It provides 5 hardware interrupt. It provides direct memory access facility. Just we have seen HLDA and hold signal is there. 8-bit stack pointer. Serial peripherals can be interfaced through two serial lines, SOD and SID, that is serial output device and serial input device. And flag register with 5 different flags, that is a Z means 0 flag, S means sign flag, CY means carry flag, AC means auxiliary carry flag, and P is the parity flags. These are the 5 different flags. These are the different features of microprocessor. So how as the technology advances, that is a small scale integration, that is SSI. SSI means small scale integration and LSI means large scale integration. So in small scale integration, the size of computer is very large, and in small scale integration to large scale integration, it is possible to fabricate large number of logic gates on a single chip, and that become the microprocessor. That means size of the microprocessor, now size of the CPU become very small, that is a single chip is there and that work as a computer. So when the technology advances and in the large scale integration, we fabricate a chip that is a microprocessor chip. So microprocessor does not include input output port, memory, timing and counters. So in the technology when advances, that is a large scale integration to very large scale integration, it is possible to fabricate microprocessors with IO memory devices on a single chip, and that becomes the microcontroller. So microprocessor is a general purpose computer and microcontroller is a special purpose computer. Then what is the block diagram of 8051? Just we have seen that what is the difference between the microcontroller and microprocessor. In microprocessor there is no input output port, no internal memory is there, and no timer and counter circuit in the microprocessor. But in microcontroller 8051 there are different things. Instead of CPU means it is a microprocessor. In addition to the microprocessor, there is a RAM is there, ROM is there, timers and counters are there, serial port is there, input output port is there. These are, and then that become the complete computer. So it is a true computer on a chip. Microprocessor is a computer on a chip, but it is a true computer on chip because it is a fulfill computer. All these things are included in the microcomputer. That is, a RAM is included, ROM is included, and input output port is also there, and serial port is also there. So this is the block diagram of microcontrollers. So this is the architectural diagram of microcontroller 8051. This also contains different blocks are there. We are going to see in details regarding this block diagram of microcontroller. It contains CPU components, central processing unit components, that is a program counter is there, arithmetic logic unit is there, working registers and clock circuits. Then it contains internal RAM, internal ROM, I/O port with programmable pins, timers and counters, serial data communication. These are the different blocks of microcontroller. So what are the different features of microcontroller 8051? That is, first is 8-bit CPU with register A and B. So all the arithmetic logical calculations is performed in microcontroller using the register A and B. Then 16-bit program counter and data pointer is there. Then 8-bit program status word, 8-bit stack pointer, internal ROM of 4 kilobyte, internal RAM of 128 byte, 4 I/O port, that is a P0 to P3, P0, P1, P2, P3 are the 4 ports are there. Then full duplex means it is a bidirectional bus, that is a serial data transmitter is there, and informations are exchanged through this serial data transmitter. Control registers, that is a TCON and TOMOD, SCON, PCON, IP and IE. We are going to see in detail in the next chapter. And oscillator and clock circuits are there. So what is the difference between microprocessor and microcontroller? So microprocessor can function as a computer with addition of no external digital parts. Microcontroller must have many additional parts to be operational. So it is we have seen microprocessor is a general purpose digital computer and microcontroller is a special purpose digital computer. It contains CPU, memory, addressing circuit and interrupt handling capacity. But in microcontroller, this and addition, that is a microcontroller have this feature as well as timer, parallel and serial I/O ports and internal RAM and ROM is there. So these are the different. So microprocessor have many operational codes for moving data from external memory to CPU. And in microcontroller may have one or two instructions for moving data from external memory to the CPU. So these are the difference between the microcontroller and microprocessor. So we can use the microcontroller in different applications. Different applications are there. Anywhere we can use. So microcontroller widely used in home appliances such as refrigerator, washing machine, microwave ovens. Then we can all this we can use robotics, printers, display keyboards, modems, charge card, phones. Then we can also use in automobile engines, then electronic security systems. In different fields microcontroller can be used. Thank you for this.